Hi everyone, I welcome all of you to this particular video. In this video, we will talk about the space complexity of bag of words. In the last video, we have seen the coding part of the pre-processing steps. So if you have not seen that video, then please go back and watch that video. And so without any delay, let's get started. See you all on the whiteboard. I welcome all of you over the whiteboard. Here we will study space complexity of bag of words. So let's see. Uh, Before continuing, let's first make a matrix representation of all of the data. Let's say here we have some reviews. Uh, as we have been studied by now, what here we will have n cross m a space complexity. And what is n and what is n? So n is basically total number of rows in our data set. So n will be total number of rows, and what is m? And m will be total number of columns. So what is total number of columns? Basically words, all of the unique words in our whole corpus, in our whole data set will be the m. So n is basically number of rows, or you can see number of reviews. Let's cut it and let's write it number of reviews. So this is n, and m is number of unique unique words in the whole corpus. So this will be the m, and and let's say we have, and let's calculate for one row how much space complexity will be there for one row. Let's say we have one row here, call it ri, and somewhere it will be 0 0, because here we will have total number of rows. So maybe some words will not be available, and corresponding to that place it will be 0, because some of the words, let's say this word here we have is not available in ri, so it will be 0. Similarly here we have come, not available, so here will be 0. And at some point, let's say some word is available, let's say ram, so here will be 1. It's here will be, let's say it's available twice times, so here will be 2. And same mango or something else, let's say we have here 4. This word available 4 times in that review, and remaining all will be 0 0 0. So everything else will be 0, 1 to 4, 3. Let's say we have 3 unique words in that particular ri. And what will be the complexity or space complexity of this particular review? So let's calculate. Here it's very simple. Let's say we have 100 dimension. Let's say we have, just for example, let's say we have 100 dimension, so space complexity will also be 100, since we are using all of the all of the columns. So we are taking space in the entire column, so it will be the 100 as well. But the main point is most of them are 0, only 3 are non-zero. So isn't it's a waste of space? So yeah, there is lots of waste of space over here. And then there we come with the toss concept, something called, instead of just you can see here we have only 3 words, and remaining all is 0. So only, so isn't isn't lots of Since there are many, most of them are zero, so loss of wastage of space coming over here. So isn't we can represent in some better way? So yes, and first I want to tell you that this kind of matrix is called sparse matrix. Sparse matrix where majority of where majority of elements are zero and very few are non-zero. And so let's move on to the next slide. Well, we'll see a little bit about this sparse complexity. So let's move to next slide. So here we will now see here we will now see about the sparsity, some of the sparsity terms. So what is sparsity? In a sparse matrix, we have something called a sparsity. A sparsity is equal to number of zero elements divided by total number of elements. So this will be the sparsity, number of zero elements divided by total number of elements. We also have a term density. Density is basically 1 minus sparsity. So this will be density. Now let's see, can we in some way can we reduce the total number of I mean, can we reduce the space complexity over here? So let's see a way how can we reduce it. Since we know that most of the values are zero and very few are non-zero, then why not why not represent in some different way? Why not we store only the non-zero elements instead of storing the all? So instead of storing the all, here we store only non-zero elements. So store only non-zero elements. How can we store non-zero elements? It's a better way. Store non-zero elements only. So how we store? Let's say of that Ri, where only it was of 100 dimension and only three values 1, 2, 4, remaining everything else is 0. Here also remaining everything else is 0. Can we reduce the space complexity here? So yes, since we have 100 and out of only 3, so can we reduce 100 to something else? Yes. So how we will reduce it? By storing it in a dictionary kind of form. Instead of storing all of the elements, store only the non-zero elements only. So how it's done? Like like at the place of say I comma j, we will store 1. Then at the place of I comma j plus 1, since these are continuous elements, so we will store 2, and then I comma j plus 2, we will store 4. So instead of storing all the elements, we will only store the non-zero elements only, and remaining else will be discarded, since we know that remaining else is just 0. So why not store only non-zero elements? And let's see what will be the space complexity from 100 to how much we reduced. Let's see, here we have only 3, so we have only 3 cross multiplied with, so let's see, 3 each. Total we are having 3 non-zero elements, or you can say each element is of taking this space 3. So each element taking 3 space, and total number of, or you can say number of non-zero elements. So what will be 3 into 3, since non-zero elements is, you can say 1, 2, 3. So 3 we have, which is 9. So from 100 we reduce to 9 only. And what will be the overall time complexity? I mean, space complexity. Let's see what will be the overall space complexity. So let's clear this. Let's make some space. So the overall space complexity will be, since we know number of non-zero elements, I mean 3, 3 will be, since is for storing the each non-zero elements, will take 3 space, which is I comma j and corresponding number, say 2. So each will take 3, which will take 3 space multiplied with total non-zero elements. Here I am not talking only for this particular review. I am talking for in general reviews. It can be anything. So what will be the total? What will be the total space complexity? It will be 3 multiplied with total non-zero elements. Let's say we have k total non-zero elements. So it will be only 3 into k, or you can say, it will be big of 3 into k space complexity, which is equivalent to big of k. So previously our space complexity was big of n into m. Now when we are storing the sparse matrix in a simple matrix form, then that, and at that time our space complexity was big of n into m, and now we reduce it to big of k. So this is the huge or tremendous amount of reduce in this space. So so this is how we store the matrix in the bag of words that we already studied, and this is the space complexity that we finally achieve for storing the bag of words. So this is it for this video. I hope this video makes sense to you as well. If you like the video, please press the like button and subscribe the channel, so that I come up, so that you can get the notification. So now see you all in the next video, and for this video, bye bye everyone, and please like and subscribe and show the support to us. So see you all in the next video. Till then, bye bye.